Okay, so today I'm mostly going to be talking about pretty printing modules. Sorry for the lengthy title. I used to work in science, and we're used to enormous titles for abstracts. So just getting started, novice Python coders might be unaware of some of the built-in or easily accessible modules that could help them print data structures in a readable format. So early in the learning process, in case you didn't hear, I'm a student at Kenzie Academy, so I'm very much a Python beginner, and most of us start out learning something very difficult so that we can kind of go through the ropes, and then we find out, oh, there's a built-in module that makes this very simple. So coders may rely on string and list functions on which they're more familiar, so things like join methods or format methods. What's that? Yeah. Sorry about that. Okay. So this talk will just review my favorite Python pretty printing modules. So I'm going to talk about pprint, text table, tabulate, and ptable, just for displaying small data structures. Each of those modules will be demonstrated with code examples. So first I'm going to start off with pprint and pretty printer. So the pprint, or pretty print module, makes output from Python data structures more readable. The output can be used as input to the interpreter. Pprint tries to return output on a single line if it can, and it breaks them into multiple lines with indentation if it doesn't fit with constraints. And it's part of the standard library, so it's pretty easy to import. So it does allow for some customization. So some of those customizations are indent, depth, and width. So if you adjust the indent, you can control for the amount of indentation on each line. Depth allows you to specify the levels, how deep in your code to print. So that's great for nested code, nested tuples. I'll show you just in a minute. And width allows you to adjust maximum characters on display in each line. So that kind of controls whether your line is going to break. And so here's an example of pprint in a list context. So I have this nice breakfast list, and I'm going to show you what it looks like when you just use the regular print module versus pprint. It lives. Okay, so a regular printed list obviously is just a single line. It's going to spread across, whereas pprint is actually going to split everything up into a more readable format, as you can see here. Also, in displaying this next example displays a nested tuple data. So the difference here is that I added the depth customization and printed that. So you'll be able to see that a regular tuple is going to print everything included, whereas this, now that I've specified depth, I only go up to 6 levels, and the rest of it you can't see. Next I used pprint in an API call. So I used this weather API and decided to pretty print that. So let me just put in a zip code here. So this is using that input format, and then I'm able to see what this data would have looked like with the regular print module versus pretty print, which organizes everything pretty nicely. Pretty printer also has a number of derivative functions, which I put into this little table here. So basically, you can use pprint with pformat, or yes pprint, or is readable, and you can do things like determine if the formatted representation is readable. And this is helpful, especially if you're going to combine pprint with logging. So the next example, I used pformat, one of those derivative functions, with the logging module in pprint. So you can see that once I set the levels to debug, I still get the same information here, but it's just in a neater displayed format. The Pprint PP is a module that requires a pip install. It's similar to Pprint, but the advantage to this one is that it's PEP 8 compliant. So just a little example here. So Pprint is easily accessible, but it's limited to basic data structures. Other structures like files or sockets may not work, and it's pretty limited in its formatting. So if you wanted to view data sets in a more readable format, like in a table, you would want to use some different modules, which I'm going to talk about next. So one of those pretty printing tables modules would be text table. Which creates simple formatted ASCII tables that might include a header, title, columns, and rows. You can adjust things like the border, the column and row alignment, and you can actually colorize some of your data using text table. It's very easy to use when creating a small data set. It does support fixed size tables and also dynamic size tables. So here are just a couple examples. So here you can see that each line you actually have to adjust the columns individually. And it'll give you something that looks like this. And then this can be a little daunting, of course, if you have a large data set. One of the limitations, it does enforce rigid rules to the table, so cells may not span multiple rows or columns, and corners must all be identical, and it only parses text tables. Another module is tabulate, which presents a formatted fixed width table for pretty printing. You don't have to do custom settings and formats every time that you add a new item to the list. It has several preset table formats. So some of those are listed here. It detects column types automatically and aligns the values by decimal points. It is faster than pretty table and text table based on some benchmarking tests. So I'm just going to kind of show you what that looks like. So again, it looks pretty similar to text table, but with some advantages that you don't have to necessarily put in format every single line if you don't want to. Because tabulate, one of the limitations, major limitations, I would say, tabulate has decimal point alignment and parses everything as a number. So it has to guess how to print a particular tabular data type. It needs to keep the entire table in memory. It has to transpose the table twice, and it does more work than it might appear for such a simple table. Again, not very good for large tables, and it may not be good for performance-sensitive conditions because it is a bit slower than some of the other modules. And finally, ptable, which is probably the fanciest module here. It's a quick way to represent data, tabular data in stylized ASCII tables. It offers a variety of formatting options. The styles can be changed all at once or as individual lines, and it can read data from a CSV, HTML, or a database such as SQL, and it can write data in ASCII or HTML. So if you want to add, you can add data row by row, column by column if you're not importing from an outside source. And here's one. Ptable also allows for some data manipulation. So you can select a subset of your data for viewing. You can change the column alignments, and you can even sort your data. So this is an example of some of that data that I just showed sorted by population. So because it has, I guess, more bells and whistles, ptable performs more slowly than tabulate or some of the other modules that have limited functionality. And ptable is currently only compatible with Python versions up to 3.0. All right. So thank you for letting me review those. Do you have any questions? Thank you.
Let me bring the microphone around because we are recording all of this stuff. So,
I was just curious what that presentation tool was that you were using.
That's Jupyter Notebooks, and it's through Collaboratory. Sorry. It was Jupyter Notebooks using Collaboratory in Google.
Thank you.
Uh-huh.
do we have any other questions?
Which of those modules do you find yourself using most often?
Probably tabulate because it's simple and I'm not using any huge data sets right now. But I want to play more with ptable. Yeah. Yes.
Just a follow-up to that question, what would you use for large data sets?
I'm guessing that there's something outside of what I've learned as a beginner. Probably, I guess that ptable would probably be the best thing out of this list, but because you can import CSV or data from an outside database and print that, yeah.
Couldn't you also just use pandas, especially because you just mentioned CSVs? So why would I choose tabulate over pandas?
Yes, that's because it is the beginner talk, and I haven't quite learned pandas yet, but yeah, it's probably way better.
Just wanted to, just a quick side note on tabulate. It does a really good job of printing data frames for pandas, so that's just one
Awesome.
nice thing I found about it. But yeah.
Awesome.
I just learned this recently at PyCon. There's actually this kind of cool library called Dataset. So like if you're wanting to explore a big data set and you don't necessarily know what you're looking for, you might want to check it out, and it'll kind of like lead you to a conclusion maybe by how simple it is to look at stuff. So it's relatively new, but it's pretty powerful. So check it out.